With the launch of the fourth orbital ATK resupply mission to the International Space Station, NASA delivered a brand new video camera capable of recording and revealing images with 6 times the detail of your average high-definition television set. And NASA wants to bring this dynamic and captivating video into your living room. So with that in mind, we sat down with NASA's Imagery Experts Program Manager Rodney Grubbs here at Marshall to talk about the future of video imagery and NASA TV in UHD. So a lot of people will be familiar with their high-definition televisions that they may have in their living room, but there's been a big push lately to go to something called 4K or ultra-high definition. Can you explain the difference for us?
So ultra-high definition or 4K, the 4 is 4 times 1080p. So if you're looking at a television set that says full HD, then it is 1080p resolution. This is 4 times that in the same space.
Is it a much sharper and cleaner image?
Much sharper and cleaner. There's many more pixels, and the pixels are smaller.
Why is NASA studying this technology?
So there's 2 reasons why NASA would be interested in shooting in this format. One is for the science and engineering applications. So if we have more pixels, higher dynamic range, higher frame rate, then that's more data for analysis and engineering purposes, right? The other is because a lot of what NASA does has a shelf life. We're still looking at Apollo films even today, all these many years later. Well, 20 to 40 years from now, somebody is going to be very appreciative that we shot in video formats that have a shelf life, that actually hold up to whatever may come in the future, 6K, 8K, who knows what 40 years from now people will be able to watch on large screens and so forth. So having something in a higher resolution today is going to be useful for many decades to come.
So you think it's helpful for historical documentation as well?
Yes, right. So you know, a lot of what we do may not seem to be that terribly important today, but there may be some science or application 10, 20, 30 years from now where somebody's going to come back and do a search and find that footage, whether it's a solid rocket booster test in Utah or an Orion splashdown. You know, the folks working on Orion have been looking at Apollo era film to understand how the capsule behaved, you know, at splashdown, for example. So you just never know how what we shoot today is going to be used in the future. If we're shooting an event, a one-time shot, you don't get a do-over. There may be something that happened that we didn't see at first. So the analysis community looks at that footage and they pore over it frame by frame. Well, if they can see in the shadows and they can see in the bright areas, or they have more frames to a higher frame rate to capture something, the higher resolution, the more frames, the better, because there may have been one little instance for a fraction of a second of something that occurred that everybody missed in real time, and they saw it in the review of the footage. Well, if you think back to the early space flight days, we flew film cameras, and we flew film cameras for practical reasons and because it had a shelf life. The same thing goes on today. So if we can have a 4K or 6K camera on board the space station documenting life and documenting the science that they do, first off, it allows us, all the rest of us that paid for it, to go along for the ride with them and really appreciate what life is like up there. Every time we get a higher resolution imaging system and we look at it here, it makes you feel like, okay, I really actually kind of understand what life is like up there. And then, as we mentioned earlier, the science and engineering applications of the higher resolution helps too. Plus, that's a very high dynamic range place to shoot. You have very stark contrast. So the better the imagery and the higher the dynamic range of the imaging system, the more natural it will appear to us when it's replicated on a screen. So it's, again, allowing all of us to go for a ride with them.
So tell us about the development of the new NASA UHD channel.
So an encoder manufacturer called Harmonic approached us at a technical expo and said we would like to talk to NASA about creating a full-time ultra-high definition satellite channel. So we went through a negotiation process. They provided NASA new encoders so that we could make room on this satellite transponder for a new channel, which basically meant we are further compressing the existing channels that we had to make room for this ultra high definition channel. And it gives us an opportunity to have experience with a new encoding algorithm, with new equipment. It also gives NASA an outlet for a lot of this 4K and ultra high definition content that we've been accumulating over the years, but really haven't had a practical way to release to the public. Being the first ones to have a full-time channel in this format is really exciting for us, and I know my colleagues enjoyed the challenge, and it was a challenge because we're so out in front of the rest of the industry that a lot of this equipment that has come into this lab to be worked with by our colleagues was serial number 1 or still in development hardware and software. So there's some frustration that goes along with that, but it's also kind of exciting to be on the very, very bleeding edge at the beginning of what may be a new revolution in television.
I can tell you based on firsthand experience, the clarity and detail of this video is really impressive, and we're looking forward to sharing it with you. But Harmonica and NASA are currently in talks with cable and satellite providers to deliver NASA TV UHD. But right now, the only way to see this new channel is A, with a UHD TV set, and B, by pulling it directly off of the satellite. And you can learn more about how to try to do that by visiting the NASA TV website at www.nasa.gov/NASA TV.